10 base or our base number system, we use the decimal system number, and all the rules are the same except the fact that in the binary system we use only zeros and ones. So I gave 6 exercises as homework to convert. The first 3 were converting the following numbers from base 2 to base 10. Let us do it together. I will write down it here, 101, 100. It is better in this whiteboard, 101. Am I right?
Yes. 101.
100. 100. Let's try only one from here and one from the reverse, not all the exercises, no problem. We are checking only the first one to convert it into base 10. It is equal to, let's start with 0 at power 0 times 2 at power 0, at power 1, at power 2, at power 3, at power 4, at power 5. So we have 1 times 2 at power 5 plus 0 times 2 at power 4, because the second digit is 0. So it is at power 4. It is at power 5. It is at power 3, at power 2, at power 1, at power 0. So we have plus 1 at power 1 at power 3, 1 times 2 at power 3, plus 1 times 2 at power 2 again, because this digit is 1 as well, and plus 0 times 2 at power 1 plus 0 times 2 at power 0. So this is 32 plus 0 plus 8. This one is 8 plus 4.
4.
The others are 0. I will not. Plus 0 plus 0 we can write. Plus 0. So the result is 32 plus 8 plus 4. It is 44. Did you find this result, 44, for the first one?
No, I started from the other side like this.
Let's do it again. 1 times 2 at power 5, because we start from the power 0 from the right. 0, 1, 2, 3, 4, 5. So we have 6 digits.
I start.
No problem. The important thing is to understand. It is not a problem if we did not solve correctly. Do you understand now? So we start from 2 at power 0 here, then 2 at power 1, 2 at power 2, the third position from the right shows the fours. This one shows the ones, 2 at power 0. This one shows the twos. This one shows the fourths. This one shows the eights. This one shows 16s. And this one shows 32s. So we have 32 plus 8 plus 4 are 44 in total. Do you understand? Let us do let us do another example from the reverse. I'm picking one from the first 3 and one other from the second 3 exercises. Now I'm going to pick up, for example, 87 or 94. let us pick 94 and convert it into binary system. Now, I'm cleaning this up, this part. 94 is to be converted into base 2. Okay, 94 divided by...
Sir,
So, yes?
in the first one, I started from the left.
In the previous one, in the previous exercise?
Yes.
So you should start from the as in ordinary numbers. It is the same as in ordinary numbers. In the right, it is the smallest digit. It is the smallest value from the right. So we start from the right, and we have the smallest number on the right. Then the numbers are going to increase. So if you want to write the number, you should follow the same rules as in the decimal system. From
Okay.
the right to the left, the numbers come to decrease. From the to increase, sorry. From the left to the right, it comes to decrease. We have 94 here, and we have to divide it by 2 in order to find the... we are interested here not for the quotient, but for the remainder, because all the remainders will be either 0 or 1, and they will form the binary number we are interested. So 94 divided by 2 are 47. The remainder is 0 here. We have 47 divided by 2. There is 23. The remainder is 1.
Is 1.
We have 23 divided by 2 equal to 11. Okay, very good. And the remainder is 1 again. We are going to divide 11 by 2, and the result will be 5. And the remainder is 1 again. We are going to divide 5 and 2. We have 2 the quotient, and the remainder is 1. Again, 2 divided by 2 equals 1. The remainder is 0. And 1 divided by 2, the quotient is 0, and the remainder is 1. So we are going to finish not here, but here when the quotient is 0. So the number should be written from,
you're right,
from the bottom to the top. We are going to write this number starting from bottom. So we have 1, 0, 1 here. We have again 1, again 1, again 1, and
1
finally
0.
0. Let us check. Is it correct? Did you find this result?
Yes.
Okay, very good. Let us check by mind very fast. We have 0, 0 times 1. It is 0. 1 times 2 is 2. 1 times 4 is 4. 2 plus 4 are 6. Then we have 8 here. 6 plus 8 are 14. Then we have 32 here. 14 plus 32 are 46. We have here 32. And here we have the number 6. Sorry, again. Here is the number of ones. Here is the number of twos. Here is the number of fours. Here is the number of eights. here is the number of 16s, here is the number of 32s, and here is the number of 64s in this position. So we have 1 times 64, 64 plus 0 plus 16 are 80. Then we have plus 8 are 88, plus 4, 92, plus 2, it is 94. The result is okay. So we can make the reverse in order to find if we solve it correctly or not. Now today I'm going to explain the addition and subtraction of the binary numbers. Of binary numbers. Addition and subtraction. So operations with binary numbers. It is the title or the name of topic. In binary system, there are only 2 digits, 0 and 1, we said last time, and any number can be represented by only these 2 digits. The arithmetic of binary numbers means the operation of addition, subtraction, multiplication, and division. So today we are going to do only the addition and subtraction. If there is time left, I will do the multiplication as well today, but division is a little more complex and I will explain maybe the next time, the next lesson.
Okay, sir.
We said binary arithmetic operations start from the least significant bit. So from the rightmost side, we start counting from the right to the left here. We said, for example, 0 times 1 plus 2 from plus 1 times 2 plus 0 times 4, etc. We started from the right to the left. We will discuss the different operations one by one in the following articles, in the following topics. In the binary addition, there is 4 steps or 4 rules. They are written below. If we have 0 plus 0, the result will be 0. It is clear.
0.
If we have 0 plus 1, the result will be 1. But if we have 1 plus 0, we will have 1 again. And instead of 2, in the decimal system, we have 1 plus 1, it is equal to 2. But here, we cannot write 2 because we have only zeros and ones. So we should write 0 and carrying the digit 1 into the next position. Like in the decimal numbers, it is the same in the decimal numbers. In the decimal numbers, you write, for example, 25 plus 47. You write 5 plus 7, it is 12. You write 2, and you carry the 1 or the tens in the next position, in the position of tens. You don't write 12 here, but only 2, because the 2 plus 10 are 12. You cannot write tens here in that place, in that position, because here it is the position of units. But you write the 1 here because here it is the position of tens. Here are the tens, so you carry the 10 here and you write it as 1 here. So instead of adding 2 and 4, you have to add 3 and 4 now, and the result is 72 in the decimal system. The same thing will be in the binary system as well, because if we have a number that is if you have a number written in the decimal system, in the binary system, and you want to add it with another number, not always the result will be 0 or 1. Sometimes the result will be 2, but we cannot write 2. because we should use only the digits 0 and 1. Let's take an example. If we have 1 here, 0, 0, 1, 2, no, not 2, 0, plus 0, 1, 1, 1, 1, let's say. Okay, we are going to add these numbers. 0 plus 1 is 1.
Is 1.
But 1 plus 1, it is 2. We cannot write 2 here. We should write 0. And we carry 1, 2. We carry to the next position, which is of a higher order. So we have now 1 plus 1. It is again 2, but we write 0 and we carry another 1 here. Again, we have 1 plus 1. It is again 2, but we write still 0 because we carry again the value 1 here. So we have 1 plus 1, it is 2. We should write still 0 and carry a 1 here, but we don't have any more digits here, so we should write only this one, this number. So the result will be 100001. Let's try to understand why is it in this way. Let's try to convert this number into decimal to be sure that we solve it correctly. We have 0 ones plus 1 2, so we have 2 here, plus 0 fours, 0 eights, and 1 16. We have 16 plus 2, it is 18. This number here, it represents the number 18 in the decimal system. Let's write this one in the decimal system. We have 1 1 and 1 2 and 1 4 and 1 8, but we don't have any 16 here. So we have 8 plus 4 12 plus 2 4 14 plus 1, the result is 15. So if we add 18 and 15, the result will be 33. But let's see if this number represents the number 33 in the decimal system or not. We have 1 here, plus 0, plus 0, because this is the number of 2's, this is the number of 4's, this is the number of 8's, this is the number of 16's, this one, and this is the number of 32's. So we have 32 plus 1, it is equal to 33. It is the same result in both cases. Do you understand? So the only thing to do is when there is 1 plus 1, 2, not writing 2 here because 2 does not exist as a digit in the binary system, but you should carry 1, 2 to the previous position, because the previous position shows a higher order of powers of 2. So it is okay. Like here, from the units, we carry 1 10, 1 to the position of tens, because tens are of a higher order than units. So the addition is like this, but we can do also the subtraction of we can do here the subtraction of binary numbers, and the rules are the same as in the ordinary numbers. I'm going to write a subtraction in the decimal system to remind the rules, and then I will explain how to do the subtraction of binary numbers. We have to subtract, for example, 128 and 79. We say 8 minus 9, it is not a natural number, so we are going to take 110 from here. To borrow, we say in maths, say we have to borrow 110 from here and write it as 18, and we have 18 minus 9, it is 9. But we have now we have not 2, but we have only 1 in this position, because 110 has been borrowed to the by the units. So we have 1 minus 7. We cannot do again that operation because the result is negative, but we borrow 1 value from here. So from hundreds, we borrow 110 and we write it as 11, and it is 0. It has remained 0 because there is not 1 anymore, because 1 has gone here. So we have 11 minus 7, it is equal to 4, and here we can write 0, or we cannot write 0. It is not problem. If you write 0, it's okay, but you are not supposed to write it. You can write only 49. Do you understand the method of making subtractions? Yes. Yes.
I understand.
Okay. So we are going to do the same thing even in the binary numbers as well. Let's take two numbers, 1, 1, 0, 0, 1. We are going to subtract them with 1, 1, 0, 0, let's say. So we have 1 minus 0, it is 1. 0 minus 0, it is 0. We have not problems here. We have no any problem in that case. But here we cannot subtract 0 minus 1 because the result is negative. So we have to borrow not 110 as here, but 1, 2. We have to write 2 minus 1, it is 1 because we borrowed a 2 from here. So it is left 0 because we removed the 1, 2 from here and place it here. So we have 0 minus 1. We cannot do again, but we will borrow 1, 2s from here, and we have to subtract 2 minus 1, it is 1, and here we have 0. We can write or not write as you wish. I am writing it here. So this is the result of the subtraction. But now we are going to say we are going to see if we made it correctly by making the proof with decimal numbers. It is not, you are not supposed to do every time this one, but until the moment that you are sure for the things you are doing, it is better to see, to convert them into decimals and to see if the result is correct. Let us convert it first. By mind, we have 1 plus 0 plus 0 plus 8, because this is the position of 2's, 4's, 8. 1 plus 8 plus 16, it is 25. Isn't it? Here we have 0 1's plus 0 2's, it is 0, that part, plus 1 4, 4, and 1 8. 8 plus 4 here are equal to 12. We have to subtract 25 and 12. The result is 13. Let's see if this number corresponds to 13 or not. Now we have 1 plus 0 plus 4, because we had 0 2's here, plus 1 4 plus 1 8, because this is the position of 8s. We don't have any 16 here, so we cannot, we are not supposed to write. There is not necessary to write the 0 here. 8 plus 4, 12 plus 1, the result is 13. So we did correctly this subtraction. Could you solve two similar exercises now as a classwork? If you understand, I'm going to see if you understood well or I should explain again. Could you
Understood.
Could you solve, for example, and give me only the result? Could you solve those two exercises? Find the sum of 1 1 0 1 1 0 plus 1 0 1 1. This is the first. And now I'm going to give a subtraction, an addition and one subtraction. 1 0 1 1 1, again 1, minus 1 0 0 1. I'm leaving 5 minutes to you to solve.
Got it. Done.
Okay, could you say the result of the addition, please? Start from the left to the right. If we read the number, we start from the left to the right. But if we are going to solve the exercise, maybe we start from the right to the left. So if we want to read this number, we read it as 11001. So could you spell the result of the addition?
1 0 0 0 0 0 1.
1 0
0
0
0
0 0 1.
0.
Is it okay?
Wait.
Did I write it? Okay. So about the
Wait.
subtraction, could you give the result?
No,
The subtraction.
there are 5 zeros. 5 zeros.
5
Yes.
zeros.
In the
0.
addition. No, the addition.
5 zeros.
Yes.
The first one is 1 or not?
Is 1.
Then you have 5 zeros and
Yes.
and a 1 at the end.
Yes.
Isn't it? Okay,
Yes, sir.
I have to write a 0 here again. Is it okay now? Okay. For the
Yes.
did you wrote in that way? Let's see about the subtraction, the result, your result. Did you solve the subtraction or
Yes.
not yet? Okay, could you say it, please?
I solved it. 1.
You have 1 here. Okay.
Yes. 0.
Yes.
0. 1. 1. Then 0.
And 0. Okay, let's
It's
check.
0.
Let's check now. Now we have the addition. 0 plus 1, it is 1. This is okay. 1 plus 1, it is 0. It is okay, but we have to carry 1 here.
Carry 1.
1 plus 1, it is 2.
0.
We should write 0 and carry 1 again here. So we have 1 plus 1, it is again 0. So it is okay
0.
as well. And again carry 1 here. We have 1 plus 1, it is